Dear audience, I would like to present my PhD thesis title, which is the evaluation of mechanical and antimicrobial characteristic of dental polymers. My name is Lilien Nagy. I work at the Department of Prosthodontics as a dentist. I have two specific goals. Let's start with the first one, which is the evaluation of flexural strengths and antifungal characteristic of polymethyl metacrylate incorporated with silver nanoparticles. Nowadays, 19% of the adult population wear dentures, and the most commonly used material is the polymethyl metacrylate, but it has some drawbacks like the fracture of the dentures and the denture stomatitis, and I would like to decrease these drawbacks of the material with incorporating nanoparticles, and we have chosen the silver because it is known it has antimicrobial effect. So our aim to assess the effect of silver nanoparticle incorporation to PMMA on the mechanical and antimicrobial characteristics. Our clinical question, how does incorporating silver nanoparticles affect the flexural strengths and antifungal characteristics of the dental acrylic resins? You can see here my PICO framework, and we hypothesized the flexural strengths and the antifungal characteristics of dental acrylic resin with silver nanoparticle is superior compared to the dental acrylic resin without silver nanoparticles. After a systematic search, we had more than 13,000 articles, and in the end, we had 24 eligible articles. We had 3 outcomes. Let's start with the flexural strengths, which is a mechanical property. It shows how the material can resist for bending forces, and there is an ISO standard for it. To use it for denture-based material, it should be minimum 65 megapascals. And we made multi-regression analysis. You can see here the 4 variables what we evaluated. And the first is the silver nanoparticle concentration in weight %, the curing time, whether it was short or long, and the immersion of the samples prior to the measurement. And the last one is the silver nanoparticle size in nanometer. In this graph, you can see on the horizontal axis the silver nanoparticle concentration, and on the vertical axis the mean flexural strengths in megapascal. And in the columns there are the immersed and the non-immersed samples, and in the lines the different silver nanoparticle size ranges, and with the different color you can see the different curing times. So we got the result as the mean flexural strength decreases as the silver nanoparticle concentration increases. And regarding the other variables, we need more data and more evaluation to make a better conclusion. Let's move on the next outcome, which is the antifungal effect of Candida albicans. The antifungal effect means the number of cells in the fluid around the samples. And here in this graph you can see on the horizontal axis again the silver nanoparticle concentration in weight %, and on the vertical axis the cell count in the logarithmized scale. And we found that the mean cell count decreases as the silver nanoparticle increases, and it was significant. The last outcome is the biofilm formation inhibitory effect for Candida albicans, and it shows the number of adhered cells on the samples. And in this graph, you can see the silver nanoparticle concentration and the ratio of the logarithmized cell count in the silver incorporated samples compared to the control samples. And the cell count was significantly reduced as the silver nanoparticle concentration increased. And we made a prediction table as well for flexural strengths, and this model estimates the mean flexural strengths for silver nanoparticle incorporated PMMA in the different silver nanoparticle concentrations and different silver nanoparticle size ranges. And you can see here that with the green fill, it shows the flexural strength is safely above the 65 megapascal, and the gray fill means it's lower than the 65 megapascals. So if it's green, it's good for denture-based material. And we made a prediction for the biofilm inhibition as well. And this model estimates the percentual decrease in cell count for Candida albicans. And on the left, you can see the different silver nanoparticle weight percentages. And we can say that, or we can see that if we incorporate 1% of silver nanoparticle, the cell count decreases by half in average. But if you would like to make a cautious estimate, then in case of 1 weight percent, if we check the upper number of the confidence interval, it will decrease by at least 20%. We had some strengths. For example, in these in vitro studies, the flexural strength was measured with the same method, and the samples were made according to the ISO standards. And we had some limitations, like the different conditions in case of the antifungal characteristics, and the other one was the low number of the studies. To sum up, the mean flexural strength decreases as the silver nanoparticle weight percent increases, and increasing the silver nanoparticle level leads the reduced fungal cell count, and incorporating silver nanoparticle into PMMA significantly reduces the biofilm formation. And our implication for the practice, we suggest incorporating silver nanoparticles up to 5 weight percent. In this way, the flexural strengths remain above 65 megapascals, and incorporating silver nanoparticle into PMMA, the prevalence of denture stomatitis is reduced. We have some future plan as well. We would like to develop a standard measurement for method for both flexural strengths and the antifungal characteristics as well. And we would like to perform these in vitro studies, and we would like to evaluate other nanoparticles as well. Our first manuscript is submitted, was submitted in last week at the Journal of Prosthodontics. And let's move on the second project, which is quite similar. And in this project, we would like to evaluate another nanoparticle, which is the titanium dioxide nanoparticles. It also shows antimicrobial effect, and it's cheaper than the silver nanoparticle, and it's biocompatible as well, so this is why we choose the titanium dioxide. Our clinical question and the PICO is quite similar, but we would like to evaluate other outcomes like the impact strength and the micro hardness. And we hypothesize the mechanical and antifungal characteristic of dental acrylic resin with titanium dioxide nanoparticles are superior to the dental acrylic resin without titanium dioxide nanoparticles. After the search, we have found more than 9,000 articles, and currently I'm working on the full text selection. So our first project is submitted, and our planned submission date for the second project is October. Thank you for your attention, and I would like to finish my presentation with a quote: "Success is the sum of small efforts repeated day in and day out." Thank you.
I have actually two questions. The first one is regarding your first plot. I think could you go back to your first one, please? I saw two colors. One is black, one is pink, I think, and they represent the different types of polymerization, if I'm right. The other one.
Yes.
Yeah. What do you mean by a short and long curing time?
Thank you for your question. The short curing, both are good according to the manual. In case of the short polymerization, we start the heat polymerization at 74 degrees Celsius for an hour, and after that we will heat it and we will boil this material for half an hour, so it will be about 90 minutes. And regarding the long polymerization, it's about 8 hours and on 70 to 74 Celsius degree.
Okay, thank you. And my second one is actually about the colors. So if you include silver nanoparticles into a denture, does it change the color of it, or is it just
Thank you. It's a really good question. It I think depends on the form of the nanoparticle. We have started an in vitro study, and I would like to evaluate the color as well, but I didn't have enough article. Some articles mentioned there wasn't a difference, but another articles they mentioned there was a little difference, or it was a little bit grayish, and I was wondering why there was a difference, or in the other there wasn't. Maybe it can be because of the form, whether it's powder or is it colloid form of the silver, because the powder is black or really dark gray, and we have started an in vitro study, and I mixtured the powder of the silver nanoparticles and acrylic powder, and I can see it was a little bit grayish in lower concentrations as well, but we didn't try the colloidal form, because the colloid can be yellowish or a little bit like orange, or it can be brownish as well, and in some articles it was written the color of the colloid can depend on the size of the silver nanoparticles, and sometimes so in the colloid the silver nanoparticles are layered or covered with some material, most of the cases with citrate, and I think it has also an effect on the color, so we should check the colloids as well. Maybe we cannot see that grayish discoloration, but I don't know if long term we use the colloid, maybe long term it can cause discoloration as well. So for the future it would be good to evaluate this as well. Thank you.
Yeah, thank you.
If I understand right, they just mix together the powder from the silver and the acrylic. So is there any other way to apply the silver to the surface? I mean, in my understanding, it's only useful on the unpolished side of the denture. So maybe just a blow of these nanoparticles with a high pressure or something like that also could work. Do you have any data regarding this?
I do not have any data about just blowing on the surface. I think if we just blow it on the surface, maybe it can dissolve easier than if it's incorporated in the denture. So I don't know. I do not have enough data about just covering with silver nanoparticle incorporated layer, but maybe it can be a good solution. In these studies, there was an in vitro study which mentioned that it's not incorporated in the whole denture, but there were 2 layers. So, for example, we can use it on the gingival part or the areas where the patient cannot see the discolored part, and the outer part, or in the aesthetic zone, it can be without silver nanoparticles. So it can be a solution if we concentrate on the aesthetics.
I was wondering about the prices. Do you know how much? How much does denture with nanoparticles cost?
Yes, thank you. I have just ordered some nanoparticles, so I know the exact price of it. I ordered 10 grams of silver nanoparticles, and it was about 250,000 forints. And but we use a really little amount of that. So if we would like to evaluate, if we would like to incorporate silver, denture is about 10 grams or 15 grams. So if we use it for 1% or 0.5%, we need about 0.1 or 0.05 grams. So I think it will be just some 1,000 forints extra cost.
So how long these nanoparticles are effective within the denture? And the other one would be any disinfecting solution which is used for the denture affects these materials or not?
Thank you. I didn't find any data about how long it's effective. I think, yeah, it's an important question. So maybe it would be really helpful and give us information if you, for example, if we evaluate the dissolving of the silver. So if we could measure the dissolving of the silver ions for long term. So thank you.
Just a quick question around this silver nanoparticle concentration. So I understand from your conclusions that you want it to be under 5%, predominantly for flexural strength, to maintain flexural strength above 65 megapascals. What's the ideal concentration, or is there an ideal concentration for its antimicrobial effectiveness?
The higher was the concentration, the higher was the antimicrobial effect. So if our main goal to get the highest antimicrobial effect, I would suggest the 5-8%, and we have the still we have the good mechanical properties. So if we're just concentrating on the antimicrobial effect, the highest concentration, so the 5-8% is the best. But I would evaluate other mechanical properties like the color and impact strength and micro hardness and so on to do the best choice.
And I know you haven't completed it yet, but the titanium dioxide, just your feeling, can you see that as a superior product? And I know we can measure superiority in many different ways, but I'm just interested in, at the moment, what your view is on that versus the silver nanoparticles.
Thank you. Currently, I'm in the stage of full text selection, but I think it can be a good alternative. Or if the mechanical properties are also remains above the 65 megapascal, I think it can be better because of the color, because titanium dioxide nanoparticles are white, so maybe it doesn't cause this grayish discoloration.
Thank you very much. And considering this, do you have a minimum weight percentage that you would recommend?
I do not have this minimum concentration because we do not have enough studies in the lower concentration. So I think I have the most. So if we check the lowest concentration, we have more articles at 0.5%, and there were some studies which were lower concentration, but we need more investigation. But according to this, I would suggest the 0.5% if we would like to use the lowest concentration.
Okay, and I have other questions. You know that polymer systems are very sensitive in terms of polymerization when the monomers are mixed. And I was wondering, do you know anything about how these silver nanoparticles could affect the final degree of conversion?
Thank you. It wasn't mentioned, or there wasn't any data about that. I have some ideas about the monomers, but not regarding the silver nanoparticle concentration, but the curing time, because maybe the short polymerization can leave more monomers, maybe, but it's faster. And in case of the long polymerization, maybe we have a lower rate of monomers, and it can has an effect on the mechanical properties as well.
Not only that, I was thinking that monomers eluting from the system can have some bactericidal effect and maybe affect your whole outcome in that term. That's why I was really wondering why you were checking short and long curing time. Isn't there a standardized curing time that is the best for that material?
Yes, I have checked the different brands of acrylic, and both long and short are mentioned in the manual, so both are good.
Future projects.
Yeah.
And does these nanoparticles, do they change the porousness or polishability of these materials?
We didn't find data about that, but maybe in the future we will evaluate it and include our studies. But it's a really good question. Thank you.
Was there a mention of other mechanical properties, like maybe it will negatively impact the hardness or surface roughness or other properties? So was there a mention of the measurement of other types of or other mechanical properties?
So how they...
like, for example, like improve the flexural strength, but on the other hand, it worsens the hardness or it negatively impacts the... So was there a mention of other types of mechanical properties measurement?
Thank you. I wanted to evaluate the micro hardness, and unfortunately we didn't have enough eligible article, but as I remember, it wasn't worsened micro hardness.
In your own study, future study, would you consider the cell count, which is, I assume, was like something like colony forming units per milliliter?
Could you
the cell count, was this in colony forming units per milliliter, the unit?
Yes, it was.
And would you consider it in your own study a continuous or a categorized variable?
It's a good question. Maybe categorized, maybe, because a lot of things can modify the cell count, so I think it would be better in a...
It was just a question because it can be both, because as far as I know, If the cell count is low, then it can be treated completely as a continuous variable, but if the cell count increases above a certain threshold, I don't know the certain threshold, then the formula will give you steps, not a continuous scale, but steps after a while. So it's just good to know.
Thank you. Thank you.